Hey people, welcome back. And in today's session, we will learn about how to calculate defect per million opportunities, which is the DPMO. We will learn about what is the definition of quality, what is the difference between the defect and defective, and how do we calculate the defect per million opportunities, defect per opportunities, DPU, DPO, and how do we convert that into the sigma level of this process. So first thing, let me just give you basic definition of defect and the quality. Defect means, definition wise, it's any deviation from a specification. In case you have defined any value as a specification, and if your output is not matching with the specification, that is the deviation from the specification, and this is called as a defect. Because of that defect, if your product is not fit for use, then it will become defective. And what is quality? Quality simple definition is fit for use. So if your product is not fit for use, it's a defective product. And if product is fit for use, then it's a quality product. Many product may have multiple defects, but not necessarily it will be defective. And many product may have one defect itself, and it will become a defective product. So we'll take an example. Before that, let's learn one more definition of quality, and basis on that, I will be explaining you about with an example what's the difference between the defect and defective. So definition of quality as per ISO 9000, it's a characteristics, basically, let's say a degree to which set of inherent characteristics fulfills the requirement. Because any product you take, any service you take, that comes with the multiple characteristics, which is called as an attribute. So here I'm using the two words. One is the characteristics, and the second one I'm talking about the degree. So basically, characteristics talks about the attribute of the product, which means what we are looking for, and the degree is the specification of that attribute. So if any product is not meeting any given attribute specification, that means it is a defect. Because of that defect, if you are not able to use your product or service, or that is not fit for use, then it will become defective. We'll take an example. Suppose if I ask you that please, you wanted to buy, let's say, one product, as in maybe one shirt for yourself. Maybe you go to the market and you are looking for the shirt. So what are the attributes you are looking for in a shirt? You will say that I am looking for the color, I am looking for a brand, I am looking for size, I am looking for material, I am looking for price, or maybe I am looking for occasion. These are a couple of attributes. Now, what is the specification, which means what is the specification or the degree for each of the parameter? So you will say, okay, color, let's say I'm looking for a black color. Brand, I'm looking for Louis Philippe. Size, I'm looking for the large. Material, I'm looking for cotton. Price, I'm looking for, let's say, $20. Occasion, I'm looking for a regular wear. These are the specification. Now you go to the market and you buy a shirt. I give you two options. And if you have to choose any one out of these two, so then I will ask you a question, which one you will choose. Now I'm putting here is the value against your specification. Suppose you receive a perfect black color It's a Louis Philippe brand. Size is small. Material is cotton. Price is maybe 20 or less than 20, and its occasion is regular. If I calculate out of this how many parameter you are meeting, so you will say that color I am matching with my defined specification. I am meeting the brand against the specification. I am meeting material. I am meeting price. I am meeting occasion. But what I am missing my size here. So this size is something which is not meeting your specification. I calculate here the total defect you have is 1. Total opportunities you have are total 6 opportunities. So defect percentage, if you calculate, this will be 1 by 6, which is around 16% are the defect in your process. So the quality will always be 100% minus defect percentage, which means it comes with the 83% quality. This is your option number 1 is giving you. If I ask you option number 2, the color which you could not get as a black color, but you got a carbon black. Now, pardon, it's carbon. Brand, maybe you got as in BlackBerry. Size you got, large you was expecting, you got a large size. Material is polycotton. Price is bit high, $22. And brand is, occasion is not regular, it's a office wear. Suppose. Now out of this, if the second part I calculate, you are meeting one parameter as a size, but you are missing color, you are missing brand, you are missing material, you are missing price, you are missing office wear, or the occasion basically you are missing. So in this case, the number of defect you have 5, where the opportunities are 6. So defect percentage will be 5 by 6, 83%, and quality will be 1 minus 83%, which is around 16%. I ask you which one you will choose out of this. Because size is a very critical parameter, so probably based on this, you will say, I am going to choose the option 2. Though option 2 has only 16% quality, while the option 1 has the 83% quality, but still you will choose option 2. Why? Because as per definition, this is fit for use. What will you do if size doesn't fit to you? Definitely you won't be able to wear. If doesn't, you are not able to wear, which means it is not fit for use. So one product may have multiple defect, like as in the option number 2, but still it is not defective. Even the 16% product, quality product is not defective, though your option number 1 is defective because it has one defect which is critical parameter to me. If size doesn't fit to me, I won't be able to use it. So then 83% quality product may be a defective, but 16% quality product will have only a defect. So simple difference between defect and defective is when the product is fit for use, like a second product, though it has multiple defect, quality is only 16%, but still it is fit for use because size will fit to you. While the first product, which has 83% quality, not fit for use. So this is the example which you can relate with any product or any service, how we differentiate the product is a quality product or not a quality product. Now, how do we calculate the DPU, DPO, DPMO? What is that? So first thing we'll see, assuming you are working in this shirt manufacturing company and on an average per month, you are producing around, let's say 2000 shirts. These are called as an unit. Now, number of opportunities you have, which can be a defect, possible defect, are the 6 parameter. These are the 6 parameters. So opportunity I will be writing here as in 6. Now what is my total opportunities? Total opportunities will be, because I am producing 2000 shirt. Each shirt can be rejected on 6 different parameters. So total opportunities will be 6 multiplied by 2000, which is around 12,000 are the total opportunities. Now I assume that suppose the number of parameters during the audit when you found are not meeting the specification, assuming as in, let's say 25. I have to find out what is my defect per unit, defect per opportunities, quality percentage or yield percentage, defect per million opportunities, what is my sigma level. All these calculation I will be doing now. So based on this data, let us understand how to do all these calculation. So DPU is your defect, what you have observed here in our case is 25 over units. Units are 2000. So as per this data, my defect per unit will be 25 by 2000, which is around 1.25% are my defect per unit. If I look for the defect per opportunities, this will be defect over opportunities, which is number of defects are 25, opportunities are 12,000, which will be around 0.2% approximately. Now, what is my quality? DPO quality is equal to 1 minus DPO. And the DPO numbers are 1 minus 0.21%. So my quality is 99.79%. Now you want to get the DPMO. DPMO is equal to DPO multiplied by M. M stands for million. So my DPO is 0.21 multiplied by million, which is 10 power raised to 6. DPMO of this process is 2083 approximately. And I want to convert this into the sigma level. So my sigma level of the process, you already know the formula. When you take the probability and put into the formula norm sin V. Here it's asking for the probability. Probability is around 99.79%. So in this formula, if I put this probability value, I will get my sigma level. Let's see here. Norm sin V. I select 99.79%. So my sigma level of the process is 2.86 sigma. Please remember, this is your long-term sigma. I will explain you in my next session what is the difference between the long-term and short-term and how do we find out. So this is the way we calculate the DPMO. What did we understand in this session? We understood what is the difference between defect and defective, how identify the defect, how we say it's a defective product, how to calculate DPU, DPO, quality, DPMO, and sigma level. Thank you so much. Stay tuned for the next session.